everybody. In this video, we're going to recap your lesson of proof positive. Okay, so first thing, we start with a warm-up, recognizing that we can solve for that x by knowing that every straight line does add up to 180 degrees. So all of these angles are supplementary. If you were to add both of them together and set them equal to 180, you can solve for x. We had several key terms here for this lesson: the addition property of equality, subtraction property of equality, reflexive property, substitution property, transitive property, flowchart proof, two-column proof, right angle congruence postulate, congruent supplement theorem, vertical angle theorem, and paragraph proof. Let's start off by reviewing our different postulates. So we did talk about angle addition postulate, linear pair postulate, and the segment addition postulate. Angle addition says that if point D lies on the interior of ABC as an angle, then the measure of ABD plus the measure of angle DBC equals the measure of ABC. Remembering also that when we label and name angles like this, we are making sure that the letter that is in the corner of your angle is the middle letter of the angle that you are referring to. Our linear pair postulate states if two angles form a linear pair, then the angles are supplementary. Remember, a linear pair is just two angles that lie on a straight line right next to each other. So if we have that, those two angles are supplementary, therefore equaling 180 degrees. Lastly, we had our segment addition postulate. If point B is on the line segment AC between points A and C, then the piece AB plus the piece BC equals the piece AC. So noticing how similar to the angle addition, if we have this line segment broken up into two pieces, those two pieces can add together to equal the whole. Another set of properties that we talked about in this proof positive lesson was your addition property of equality, saying that if A, B, and C are real numbers and that A equals B, then A plus C equals B plus C. Here we did an example saying that if I have two variables, x and y, and they're equal to each other, if I added the same amount to each variable, they will still be equal. Similar to the subtraction property of equality, if I subtract the same amount from variables that are known to be equal, those values will end up being equal as well. The reflexive property says if A is a real number, then A equals A, which is just stating that if I have the number 12, it will always equal the number 12. If I have line segment AB, it is equal to itself, AB. If I have the angle XYZ, it will always be equal to itself, angle XYZ. The substitution property: if A and B are real numbers and A equals B, then A can be substituted for B. That's saying, again, if I have A equals B, and I had B shown in an equation like this, B plus 10 equals 18, then I could also say A plus 10 equals 18. The transitive property is similar to our substitution, but think of it like a train, because we are connecting several pieces to come to a final conclusion. Saying if A, B, and C are real numbers, A equals B, and we know that B equals 20, then A must equal 20. So 20 is taking place of this C that was given in that statement. Here's one of the practice problems that we went over. Here we were trying to create the subtraction property of equality using the diagram shown separately. So here we have some angles, and I could say if AEC is equal to BED, then I know that if I took AEC and subtracted out BEC, that is the same as if I were to go BED and subtract out BEC. So seeing how AEC and BED were equal to each other in the subtraction property of equality, and I'm subtracting out the same thing from both of them, therefore they can be set to equal. Here we're seeing the subtraction property of equality happening for a line segment, saying if AC is equal to BD, then I can take AC and subtract away BC, and that's the same or equal to taking BD and subtracting out BC. Again, we are taking something that is equal to each other and then subtracting out something that I know is to be equal because it is the same thing. And that's the subtraction property of equality. Another example here, I'm going to refer to this angle with the letter A, and we're going to use the reflexive property. Remember that the reflexive property just means that everything is equal to itself. So taking into account this angle and applying the reflexive property, we could say that angle A is equal to angle A. As we look at this next one, I'm going to refer to the diagram angle A here and angle B to do the substitution property. So something that I know here in these diagrams is that angle A is equal to 90 degrees. Angle B is also equal to 90 degrees. By the substitution property, that means I know that angle A is equal to angle B. We also know that by the right angle congruency property, right? All right angles are equal to each other. Moving down to this next diagram, I now have 3 angles, and we're going to use the transitive property on these angles. So something I could say is, if I know that angle A equals angle B, and then I know that angle B equals angle C, then by the transitive property, I know that angle A is equal to angle C as well. Now let's take a look at this worked example. You've seen this type of proof as a flowchart in your Mathio workspaces. If you haven't, make sure that you are catching up with them. So this worked example says you can complete a flowchart proof of the conditional statement if the line segment AB is congruent to the line segment CD, then AC equals or is congruent to BD. So I know that this if part is our given. This then part is what I want to prove, which is what should be in my very last bubble. So we're always starting with our given. The line segment AB is congruent to CD. Reason is that it's given. From there, I can state that the measure of AB is equal to the measure of CD, which is the definition of congruent segments. Pretty much just restating this right here. From here, we go on to note that the measure of AB plus the measure of BC is equal to the measure of CD plus the measure of BC by the addition property of equality. And behind that, I'm using the reflexive property, knowing that the measure of BC is equal to itself, measure of BC. From this addition property of equality, I can now go ahead and use the substitution property to say that the measure of AC is equal to the measure of BD. And that's because of the segment addition postulate. The fact that AB plus BC equals AC, and then BD Also, CD plus BC is going to give me the length of BD. So both of those being segment addition postulate to back up this substitution property. Therefore, now we can say that AC is equal to BD by the definition of congruent segments. In this next work example, we are seeing the same proof being proved out. However, it is now in a two-column proof. If you prefer a two-column proof over a flowchart proof, that is totally okay. So take a second to pause here and look if this makes sense to you. Note that these statements and reasons are all the same as the flowchart proof from before. In this next segment, we're going to talk about the congruent supplement theorem. So here, considering what you know about angles, you might conjecture that if two angles are supplements of the same angle, or the congruent angles, then the angles are congruent. We're going to go ahead and prove this. So pause here to take a closer look at this diagram. We have angles 1, 2, 3, and 4. And these are the angles that we're going to refer to in our proof coming up next. This proof we're going to walk through as a two-column proof. So from that diagram, and you can always rewind, we know that angle 1 is supplementary to angle 2 because that's given from the diagram. Angle 3 is also supplementary to angle 4 given from the diagram. We're also told that angle 2 is congruent to angle 4 by those angle markings we saw on the diagram. Our next steps from here is we can say that the measure of angle 2 is equal to the measure of angle 4 because of the definition of congruent angles. We then know also that the measure of angle 1 plus the measure of angle 2 is equal to 180 by the definition of supplementary angles. Same with the measure of angles 3 and measure of angle 4 equaling 180 degrees by definition of supplementary angles. Now here's where we will get into those other properties that we've learned about earlier. I know that the measure of angle 1 plus the measure of angle 2 is now equal to the measure of angle 3 plus the measure of angle 4 by the substitution property because of these two lines prior. Okay, since they're both equal to the same value, I can substitute these equations to equal each other. Then by the subtraction property of equality, I can figure out that the measure of angle 1 is equal to the measure of angle 3, and that comes from the fact that I knew step 4, measure of angle 2 plus the measure of angle 4. Here, these are two equal amounts, and if I were to subtract them out, I am just left with the fact that the measure of angle 1 equals the measure of angle 3. Therefore, angle 1 is congruent to angle 3 by the definition of congruent angle. The next diagram we are going to refer to is this one right here. We've got an X with lines and angles 1, 2, 3, and 4. Pause here if you need to take a closer look at this diagram. We are going to go ahead and prove our vertical angles theorem. So here's our proof for our vertical angles theorem. Step 1, we know that angle 2 and angle 3 are a linear pair because that's given from our diagram. Angles 3 and angles 4 are also a linear pair given from the diagram. Therefore, angles 2 and angle 3 are supplementary angles because of the linear pair postulate, and same thing, angles 3 and angles 4 are supplementary angles due to the linear pair postulate. Then we can put in stating the measures. Measure of angle 2 plus the measure of angle 3 is equal to 180 degrees, and measure of angle 3 and measure of angle 4 is equal to 180 degrees by those definition of supplementary angles. Now, we are skipping a few steps here. From before, we would have also talked about the substitution property, saying that the measure of angle 2 plus the measure of angle 3 equals the measure of angle 3 plus the measure of angle 4. And then noting that we have the measure of angle 3 on both sides of my equation. Using our substitution property of equality, I can take out the measure of angle 3 on both sides, leaving me with measure of angle 2 equals the measure of angle 4, and then concluding that angle 2 is congruent to angle 4 by the congruent supplement theorem. Therefore, we are allowed to go ahead and use the vertical angles theorem as a given. Last piece of practice we have here from our lesson is concluding the properties given each statement. So part A, if we have angle H equaling or being congruent to angle K, and that K is congruent to angle M, therefore we know that angle H is congruent to angle M by the transitive property. B says the measure of the line segment MN is equal to the measure of the line segment OP. And if I had the measure of MN plus the measure of RS, that should equal the measure of OP plus the measure of RS by our addition property of equality, because we are adding something that is the same to things that we have stated are the same as well. Part C, we know that the measure of angle T is equal to 34 degrees. Also, the measure of angle W is 34 degrees. Therefore, by the substitution property, measure of angle T is equal to the measure of angle W. Part D, we have the measure of angle A plus the measure of angle B equals 180 degrees. The measure of angle A plus the measure of angle C is also equal to 180 degrees. Therefore, the measure of angle B is congruent to angle C. And this is by the congruent supplement theorem, because these two are supplements. Therefore, we can already state that B equals C because A is going to equal A itself. E, we have the measure of angle V equaling the measure of angle V. They are the same thing, therefore we have the reflexive property. And lastly, part F, from the diagram, I see that angle 1 is congruent to angle 2, and that's due to the vertical angle theorem. Make sure to review this video as many times as you need to, pause, rewind, fast forward, and this will take you again through your proof positive lesson.